Hey, welcome back, everybody. It's time for Making a Connection, the Antaira podcast. Brought to you live here on Orange County's only community radio station, octalkradio.net. With our guest today here. Today we're going to talk about something, well, maybe you don't hear this discussed very often here. It's fiber optics and you. Yes, we're going to talk with an expert who's going to help us dispel some of the myths that many of us may have about using fiber optics, particularly in network connections. Welcome, if you will, our expert in the topic today, David Zawicki. Did I get that right?
Yep, that's right on.
You obviously work for Antaira, and you've worked with fiber optics a bunch before. Why are there misconceptions? What are the misconceptions surrounding the use of fiber optics in networking? It's certainly prevalent. It's the way the world's moving. We've moved away from all the other ways to connect stuff, the kinds of cords and connections. Fiber optics seems to be in our future. Why is this still confusing to many?
Well, I think that with fiber optics, there's been a lot of new developments that have made it a lot easier than it was to handle in the past. So I think if you talk about fiber optics in the past, you will hear people say, oh, well, it's, you have to be very careful with the fiber.
I have heard that, yes.
Yeah. So, that's just one aspect of it. And then it can be very expensive because it's fiber optics.
That seems to be the big one. This is fiber optics. It's not just a simple cable. This is don't mess it, don't cut it, don't ruin it. Oh my goodness, get it right. Yeah.
Oh yeah, and if you breathe on it wrong, it'll never work.
Yeah, right.
That's what they say. And some things are true, like terminating the fiber, putting an end on it so that you can plug it into something. Mm-hmm. That's still difficult to do, but not like it used to be.
So for the uninitiated like me, let's just walk through this kind of quick evolution. Fiber optics came about when and how, and what advantages did it give? It seems like you're using photons instead of electrons, so it's not going to give off heat, and you can pack more data into it. And those are the two things I always heard why people move to fiber.
Well, yeah, there's a lot of great reasons. I think the number one reason that people want to move to fiber is for distance. Mm-hmm. If you plug in, your home computer using one of those, copper cords.
Yeah.
And you can get
the twisted pair, as
that's
they call
right.
it. Right.
Twisted pair with an RJ45 connector on the end.
Yeah.
Or modular, if
right.
you
You see little two pieces of copper in there, whatever it is.
Yep. Yeah. It's actually got 8 connectors in there.
Is that what it is? Okay.
Yeah.
The veins, I can sort of look at it. It seems like it's copper in the vein there or something. Yeah.
Well, the older ones had 4, but the modern gigabit Ethernet over copper is 8 connectors, and you can get 100 meters out of that, and that's about it. That's not going to get you across the street or across a campus or something like that.
No.
Gets you to most places in a building, though. So for like a corporate network, that's pretty much what everybody's using. Mm-hmm. They may have to put a switch, like a junction box.
And is it true that they can get more data into that little pipeline there? That's always what I've been told.
In the fiber?
Yeah.
Yeah. So, well, let me talk about that in a minute, but because that is a myth, sort of.
Okay.
It is and it isn't. So, but the distance you can go with fiber, you can go 100 kilometers easily.
100 kilometers.
Yeah.
That's like we're talking miles now and not meters.
Yeah, if you're in
feet.
miles, it's like 600 or 660
with
miles
one wire. I can go that far.
Well, that's with fiber optics. Yeah.
Yeah.
You can get 100 kilometers. Actually, you can go a little bit further than that. And this isn't fancy stuff. The real fancy stuff that the telecoms are using can go much further.
And does it bleed? Does it leak along the way the same way electrons do bleed and fall out of the wires here?
It doesn't necessarily fall out, but the purity of a fiber of the glass is not perfect. So, it eventually a little bit of resistance, some little particle here, some little particle there, mm-hmm. definitely slows down the photons and causes some issues at distances.
But is there less data loss with fiber than there is over traditional copper twisted pairs, or no?
Well, yeah, at at those distances, the fact is that if you're talking about a 3-meter cable, the loss is almost non-existent on both of them.
Okay.
Because it's designed to be that way, to get gigabit speeds.
So let's talk about some other reasons. I just tried to look up some of these beforehand. I'm certainly not an expert like you guys are here. Resistance to electronic magnetic interference, EMI.
Yeah, so that's probably the second reason that people would use this. If if you're not overcoming distance, you might have a factory, and in that factory, actually, there used to be a Vans shoes. Everybody knows Vans shoes, right?
Sure, sure. We've had the president of Vans shoes here on our station.
Yeah,
a
they used
couple
to be in Chula Vista. They used to have a factory in Chula Vista,
times. Okay.
and they used to have copper cables connecting all of their devices, and they had one that put the sole on the shoe, and it would create this big electric magnetic influence would come off of it. So it would be a big motor would surge, and copper cable. If you run a copper cable along the way, it acts like an antenna, right?
Mm-hmm.
And that just absorbs that energy. And then
We
the
have that
energy.
in our studio. We have to worry about, electronic EMI interference
Yeah.
and stuff with the cables we use, because I don't think we are using fiber optics. I'm not sure if we are or not.
Well, if you're going short distances, it usually doesn't matter. And if you don't
Right.
have a large magnetic influence in the area, then you don't have to worry. But in this case, they did, and it was enough of an energy burst going down each end of it. It would actually reboot the computer. It was interesting. Yeah,
Wow.
it was an older computer. This was back in the 90s at some point. So the computers today are a little bit
So
better
instead of
built.
putting the sole in, it probably took it out or something, or it didn't do anything, I suppose.
Well, no, the soul went right on. It's just the computer monitoring it stopped.
Well, not in these days with the machine itself is connected. We're going to talk about that when everything gets connected to the
Yeah.
internet. But let's just continue down
So-
the key reasons why people have made this switch to fiber. One is distance, one's resistance
Yeah.
to EMI. Another one that came up in my quick discovery was electrical isolation. What the heck is that?
Sure. So think about if you had a surveillance camera on the outside of your building. Now we're here in Southern California, and I can't even remember the last time we had a good electric storm.
No.
But if you are in Florida, let's say, or
Yeah.
Tampa, the
Right.
capital of
Lightning
lightning,
storms,
yeah.
yeah.
So you have a camera on the corner of your building, gets hit by lightning, and it's connected using a copper cable all the way to your, I don't know, $100,000 Cisco core switch.
Yeah.
The chances that it blows the switch up isn't very high. But, do you really want to chance that at all?
Yeah.
So you might isolate it with a length of fiber optic cable because that electricity won't flow through the fiber.
Makes sense, right?
Yeah.
Because it's the electrons don't go through that.
Right, yeah, it just can't pass. You'll lose the camera, though.
So in the same sense that I'm putting in my home, I'm putting all these surge protectors in. This sort of acts like a surge protector
Yeah.
in a weird way.
Exactly, like a surge protector.
All right, and then fiber optics security. Is it any more secure? Is it tougher to hack, or is it safer to use fiber optics than it is copper cables?
Yeah, so I've been to a few security shows where the government is there.
Right.
And I don't know the guy's name, position, or anything, but he was a government agent, and he came up to me and he said, yeah, we can hack your copper network from across the street.
Mm-hmm.
He goes, but what we can't do is hack a fiber optic network unless we can get our little hands on it. Once we get our little hands on it, then we can tap into it without you knowing, which is also something that was believed in the past, that you couldn't tap fiber without somebody detecting it.
Really? I never heard that before. Somehow it's easier to detect that someone has entered the line somewhere here?
Yeah, you should, if you think about it, somebody would cut the line, splice in something. Well, obviously you're going to sense that cutting,
Right.
Then there's the one where you just kind of shave off the top layers of it, and then you can sense the light that's going through it. Well, that will create the light to be a slight dimmer at the other end. So you should be able to sense that too. But, give it to our military. They found a way to do it without...
They didn't tell you how, but they...
Oh, no. No, this was an unofficial conversation.
Because somehow I think traditional copper, like we've used in RJ45, as we've used in phone lines, whatever, somehow that seems to be easier to cut into and break or do something. Or is it just because it's electrons and I can somehow...
Yeah,
I don't know,
it's
somehow
the
tap in.
electromagnetic influence that it
Right.
lays off. Anytime you send an electron down a copper cable, it emits like an antenna.
Yeah, right.
So then they're just sensing that antenna, and they can sense what's going back and forth.
Yeah, exactly. That's what they say. You can literally drive up. That's the fear in my neighborhood. people could, with the right devices, can just drive up and down and get into my network here somehow without actually even cutting into it.
Yeah.
All right. So security. So you think it's been billed as being more secure. Maybe it is, maybe it still isn't, but it seems like it would be.
Well, I'll tell you this: the president of the United States has a phone on his desk,
Mhm.
and that's fiber going to it, and not copper.
Not copper. So what does that tell you? Okay. And then obvious one, lightweight. It's got to be lighter weight.
Yeah.
Easier.
So that one I've
to deploy.
seen where a guy had a robotic arm that had to swing really fast, and didn't want to put all the weight of the copper cables on it. So he used just a single strand of fiber to reduce the weight.
And again, the theory is he could put more data, maybe or maybe not, but he can put more data into that, so he doesn't have to have as many.
Well, that's the true and false thing. So you know
Right.
the whole thing: what weighs more, 100 pounds of feathers or 100 pounds of rocks, right? So
Yeah.
here's the question: what's faster, gigabit Ethernet across fiber or gigabit Ethernet across copper?
Yeah.
Right.
I guess.
But that's a trick question because yeah, it's still gigabit, but I can put multiple gigabit connections across the fiber, and I can't do that across
That's right.
copper.
That
And
makes sense.
That's how you get it. You multiplex it together.
All right, and then my original question about was kind of what we're talking about, bandwidth. You know, can I stick more? It seems like it's this is a terrible analogy, but it's a fatter pipeline. I can get more data through it. If it's truly a pipeline, like I'm pushing water through it, I can push more data through a fiber than I can copper.
Yeah, that's basically it. Is you multiplex it through there. Use different frequencies of light. So there's only one frequency of an electron, right? It's
Yeah.
But with light, you can have multiple colors.
Oh, yeah.
And so you can send some light through at blue, and you can send some light through at yellow, and then you can multiplex that out on the other end and separate them, and thus you can have multiple connections going across.
So obvious, never occurred to me.
Yeah.
I people just say, I've just taken that as gospel that they can get. It's a bigger, fatter pipeline. I never really sort of understood why. All right, so all of those sound good. I get why everybody wants to go to fiber, bigger pipeline, perhaps more secure, more isolated, resistance to EMI, certainly longer distances, lighter. May not be cheaper though, is it? Is it more expensive?
Well, yeah. No, here's the that's the interesting part that.
Because copper's gone up in value so much.
Right, exactly. You hit the nail on the head right there. Copper's gone way up, and the production of fiber has gone way down because basically companies like Corning have gotten so much better at producing fiber that they're making it cheaper and cheaper and cheaper. And per foot, it's actually cheaper than the copper. Now, there's other expenses involved when you use fiber, and that's termination. It's still terminating the fiber, putting an end on it. That is more expensive because with a copper cable, I can do that with like a little plastic module and a pliers looking thing, and I can put an end on there pretty quickly and easily. To do that with fiber, it does take a little bit more expensive equipment and a little bit more time.
So everybody listening, to your key audience listening, that aren't just consumers like me, or they have a pretty sophisticated understanding. They've probably been nodding all along in here. So if we're going to move to fiber for all these reasons, if we have moved to fiber, I don't know what do we have any idea what the percentage of copper is still out there? If we looked at all the cables all everywhere in the world, have we passed the tipping point? Are we mostly fiber now, or are we still trying to get there?
Oh no, we're mostly still copper because the vast majority of networks are enterprise networks. This is networks like you would find in your regular corporate world.
Right.
And that's 90% of the networks that are out there. And it's easy for them to run a copper, cable and terminate it really quickly.
They're familiar with it. They know it. They've been doing it.
There's no reason none of those reasons we discussed.
Don't need the security.
Yeah.
Don't need the lightweight. Don't have to go long distance, et cetera, et cetera.
Yep.
Yeah.
So that works great for them, and so that's why you end up with a lot of that. Now, where you do see a lot of fiber is, in campus environments. So if you're in a campus environment,
We're
you
at the University of California, Irvine's Beale Applied Innovation Center here today as we tape this.
Yep, and I'm sure that there's fiber between every one of these buildings.
I would think it is. Yeah, I think they've touted that as part of the advantages of being here. I know when we came in as a radio station, we were very concerned about bandwidth because many of the buildings we've been at, despite what they tout, our bandwidth was not what it was supposed to be. As we go to video and other uses as well, we're trying to live stream this stuff. A lot more than what was envisioned when they built most of the copper systems and most of the big high-rise buildings there.
Yeah, and if you think about maybe a division, a single division in this university might have two buildings, and they want to communicate rapidly, share large files or something like that.
Large files, yeah.
And they want to do it across a dedicated fiber line.
And secure and over a distance and et cetera, et cetera.
All those reasons.
All right, so all those are good reasons. Now, but the purpose is just to go a little deeper in here. And now you're going to take me, that I sort of get. Now this is for your audience who's saying, okay, come on, we know that. Let's go a little deeper. Making a fiber connection differs from using common twisted pair cable. How?
Well,
How's that any different?
I'd say the biggest problem is the termination. So the termination really makes it different.
Is it just the plug we're talking about?
Yeah, just the plug putting on it. And but let me tell you the reasons that you have to look out for.
Okay.
The things that you need to know when you're putting in a fiber optic cable. So the first thing is there's two different main types. There's this thing called single mode and multi-mode.
Okay.
And we definitely don't have the time to go into it here, but
Just know they exist, right?
yeah. And so one is made for shorter distances and one is really for longer distances. Multi-mode is typically inter-building. So in one building, this would be that EMI application. It's not going a long distance, but we want to use it to get away from the EMI.
Right.
And then the other one is like in a campus environment or from traffic light to traffic light, or even from city to city. We can run single mode. So you want to make sure you match that. You have to match your optical transceivers on both sides. They have to match the fiber type. So there's three things: the optics on one side, the optics on the other side, and the fiber all have to be the same, either single mode or multi-mode.
And that doesn't just automatically come that way.
It doesn't come that way at all. And I've actually run into a lot of people with that problem. They can use single mode optics on a short piece of multi-mode fiber in a data set, in a test bench. And then when they go to run it out into a real world application, it fails. And it's just...
And everybody goes, why? and here's what surprises me as just an every man observing this. You would think that the people who are in charge of the network here at UCI, or any place, a big enterprise, giant company, would all know this. Because they're in charge of the network. But you pointed out that doesn't mean they know how all the devices and the fibers and the optics, all the cables and everything work in the connectors. They understand the architecture of it, but they may not understand the implementation and the hardware part of it. Is that true?
Well, I think if you're the first time using fiber optics, you can run across these and you can stumble on these things. Now, a seasoned network engineer would never have these problems. But a lot of the customers of Antaira that's not their focus. They're not seasoned network engineers. They are automation specialists.
That's right. They know how to automate factories. They know how to automate some process. So that's a different breed of cat, a different background in studying than trying to figure out how to flow data from one point to another.
Yeah, they're working on how to program PLCs and HMIs and not worried about connecting them. They just want it to work connecting. And so they didn't really focus in that area. So these are the guys that sometimes, the brilliant guys, they're just not.
And it would be safe to say that when we're now automating the factory, or you do other crazy things, automating traffic lights for cities and things like that, all the oil wells and cameras on oil wells in remote odd locations, they don't often take into consideration, they think it's just a box, it's just a switch, right? What's the big deal?
Yeah, that's the thing. They think a network switch is just a junction box. Like if you had an electrical junction box, you just plug in, more things.
Yeah.
And it does work that way to some degree.
Give me more ports, give me more plugs, and that's it. But the box is a box. It's sort of a dumb thing. Right.
That's what most people believe, because that have never had to learn more than that. But there's actually quite a bit more to it in the training of that. And actually, it takes a long time to kind of walk somebody through the whole process. Now, again, the engineers that are doing enterprise networking, this is basic stuff. They learn this
Within a
early on.
building, within an office, something.
Yeah, they've learned how a switch truly works. But
Right.
these, industrial network engineers, they're not really network engineers. They're more involved in programming and stuff like that.
You gave an interesting example, just a hypothetical we made up here. You're trying to explain this to me as we were talking about this. And you said, so supposedly somebody makes lipstick. I got a lipstick factory here. And there's a little canister, right? And I have to jam the goop in at the lipstick, and some little machine does that. Grabs the little canister, fills it up, compacts it, does something, presto. And that's a miracle that we've learned how to automate. The humans used to do that 100 years ago. Now it's some machine does that. Okay, that's pretty obvious. And some CEO says, I want to know how many times it fails. How many of those little canisters jam? How many times bad ones do we throw away? Some bit of data about that little simple process. We make 100 products. I want to know what's going on in that one. And so somebody says, fine, we'll get up the internet, right? Somebody will put a little monitor, a little sensor, a little something in there, and we'll just collect some little data point. That sounds pretty simple. Why can't I just go to Best Buy and get a little router and boom,
Well,
hook up a wire? And the tough part is coming up with some way to sense it to what happens and collect the little data, write a little program that collects the data and transmit. The transmission of that data isn't the hard part, is it?
no. That's actually the part of a bigger problem that we're seeing everywhere in the United States and pretty much worldwide, and that is taking automation that used to be isolated,
Right.
and as soon as you connect it to the internet, just so you can collect some basic data, you're now exposing it to attack. And
That's the huge, and boy, are we getting that. We're living, this is in the summer of 2021 here. We just had the giant, what was it called? The East Coast network that had all the
Yeah,
power,
the whole pipeline.
whole pipeline.
Yeah, the whole pipeline went down, and that's. I don't know exactly the details of that one because I did not read enough about it. But in general, what we have is a network like, let's take a sewage treatment plant because most people think that's pretty benign.
Yeah. Right.
And so you have a sewage treatment plant, and most of those are what we call isolated networks, meaning that they're not connected to anything on the outside. They're just on the inside. So they've been engineered to only be connected on the inside.
Right.
Well, that really reduces the
And the remote,
exposure.
nobody can literally drive out there and hack into it, and they're
Yeah.
behind fences, and it just seems like it's safe. It lives in its own little world here. But somebody has to drive out and read the meter or do something. And
It's pretty safe, but you always have there's always somebody that can take their laptop in and cause it to hack.
sure,
And
if
but
they're there.
if
right.
they're there, yeah. Well, the sewage treatment plants are usually fully
Staffed,
employed and
right.
staffed. Yeah, but the problem is that I want to see. Put me the head of Orange County here, and suddenly I want to
Poof.
know that
Yeah.
I want to know how well all of my sewage treatment plants are doing. I want to see stats on them.
Right.
Like you said, we hook them up with a little router, and suddenly they're on the internet because that's the easiest way to get the data to a
Clearly.
centralized device. And now you've led a nice little path for a hacker to come back into it. And you might think, well, what do I care? It's a sewage treatment plant. Well,
Shut it down and find out who cares. Yeah, right. Mess it
well,
up.
yeah. I mean, it doesn't even take much either because, there's a lot of workers at the sewage treatment plant, but they're not doing most of the work. Most of the work is done by bacteria.
Yeah, right.
And
right.
so these pools of bacteria
Eating this
are
stuff.
kept at like perfect conditions. So all you do is have to heat them up a little bit or chill them down and kill them off, and suddenly your material is not being processed properly.
And your water's unsafe.
That's right.
Wow. Okay, so we take this too lightly. We treat it, and as we talked about in the last show, what Antaira does, you just make this one little piece of the pie, which everybody thinks is so simple. It's a little router. It's a little switch. It's
Yeah.
just something to connect a complicated machine to the internet to collect data about it. And yet, we just touched on a couple of things. Just the cable itself you choose, fiber or twisted pair copper cables, and the connections you use and matching all the stuff, that can have an impact. But here you got to go in and match anything. All these systems are all 100 years old or mismatched. The companies have merged. They bought different technology. They never thought about connecting it all together. They're not really well versed in how to connect it all together. And you walk in and stick your one piece there, and what? It doesn't work, or it fails, or it's not secure and people break into it, or the box itself, because it's in it's near a water treatment plant, and it gets wet and it breaks, and it's at the bottom of the ocean, it's the top of the mountain somewhere here. So it seems like you've got to do 3 or 4 things they hadn't thought about. Security, number 1. Connectivity, number 2. Reliability. It's got to stay up and work no matter what. I can't have that break. I don't care if at my home it's inconvenient, but I can't have the water system go down.
No.
And it's got to do it in outdoor or severe environments.
That's right. Wide temperature ranges and all kinds of vapors. You'd be
Vapors.
surprised.
I never even thought about
Yeah.
vapors. Okay.
A very corrosive gas is ammonia,
Really?
and that's
Okay.
that's what's coming out of your sewage treatment plant.
And so it's eating away at all this stuff and
Yeah.
corroding it, doing it. So they don't kind of think this, and then they call you guys in, and you have to fix this, or you have to make it fit into something where they have the wrong fiber. You said 3 or 4 points. The connectors on each end have to match the cable, and all of a sudden you start going, no, you got it all set up wrong here.
Yeah, the guys, like I said, the guys that let's take the sewage treatment plant. They usually are using industrial environment equipment to start with. They're smart enough not to use something from Best Buy or something
right.
like that.
But
'Cause
that's the temptation. If I'm a small factory, I'm not a giant factory, but I'm a small factory, and I just want to get a couple points of data. So let's just hook that up.
Sure. I mean, people do it all the time, and then they come to us, later. And guys that are new to this, they'll call us up and they'll be like, "Well, why is your router or switch 10 times the price of the one I can buy,
Yeah.
on
Because
Amazon or
it's
something?"
secure and it's tougher housing, and it probably has some sort of backups or it's redundancies
It's
built
got
into
some
it.
redundancies in the power. It's built into a stronger container. It handles vibration, and it can do the wider temperature ranges, and
And you guys can hook it up to all these other crazy things, even when I've done it wrong, like we're just touching on today. Just the simplest of things. I chose the wrong fiber cable. I didn't put the right connectors on it, and gee, why doesn't it work?
yeah, there's a bunch of reasons. Like I mentioned, you got to make sure that you're using the right type of cable, multimode or fiber, multimode or single mode. The speeds, a copper cable, when you connect it up, it auto negotiates speed. If one side's running at a gigabit and the other side can only run at 100 megabit,
Really? I
the
didn't know
gigabit
that.
will say, I'll slow down for you. But at fiber, it doesn't do that.
Keeps racing along.
It has no idea, so it just does its own speed. So you have to match that.
A couple other things. So give us some other takeaways. I got to match the fiber type. I got to match the speed. This is a key characteristics if I'm going to make this fiber connection work. What other? Got any others?
You got to have your frequencies. Remember, we talked about different light frequencies going through.
yeah,
You got to make
yeah.
sure you're matching your frequencies of light. Now there are some basic standard ones, so it's pretty hard to fall afoul in those, but you can. So you got to watch
Because
that.
can I fine tune it? It's a little bluer, a little greener, and it gives me another pipeline or something. Is that what you're saying?
No, you got to get new transmitters. The transmitter, the optics on the side are almost always fine-tuned to a specific. There are ones
But
that
I
you
could-
can adjust,
I
but
can adjust them
they're
somehow.
super expensive.
I would think
You
so.
would just want to buy the ones that are pre-made.
How about, again, back to connectors on the fiber? Is it supposed to match the connectors on the transceivers?
Yeah.
Is that simple?
It's just as simple as trying to plug a European plug into an American outlet. It just doesn't work, right? So it's the same thing here, but just like for those plugs, there's adapters. That's the last one that you have to worry about, because you can always find an adapter to fit one connector to another connector. It's not elegant, but it's doable.
You guys make industrial networking switches. Is that the best way to describe this here?
Switches and routers and wireless devices
But it's for the industrial uses.
for the industrial environments.
The
Yeah.
industrial world, this new Internet of Things, where every little piece of machinery in the factory, not just the factories. Give us some other uses. I mean, I think of factories. I get that right away. I didn't know all that the traffic lights are all
Yeah, the
connected.
traffic is I'm most excited about that, because I have personal feelings about it, because as soon as we get to a point which we're not at yet, is we get all of our intersections interconnected. Now we can write an algorithm that optimizes traffic through,
Yeah, it
through a
starts to
city.
flow.
Yes.
What it doesn't do here in Southern California, flow. And you got windmill. Look on that diagram there. You got windmills. What else do we got up here? We got factories. We got solar. We got security. Oh yes,
Yeah.
and buses. You even-
Buses, yeah.
how do I get buses hooked
So
up to the internet?
yeah, well,
And why?
the bus. Well, so you pay. If I don't know if you've been on a bus lately, but
Well, yeah.
you usually don't pay with money anymore.
No.
Right? So you slide your card through. Well, where does that information go? That information gets collected as the bus pulls into the station when it's done with its day. All that information gets uploaded to a central computer and collected.
There
So
you go.
we're on board that bus.
And then we start to get this mysterious thing called the big data. How many people? Who? How often? At what times? You know, wow, I take that simple credit card information and use it in other ways that might give me some picture of how the buses are being used and when and where and why. And
Well, there's also video. So, they collect the video for
Yeah, right.
security reasons.
Everything's got video and security these days. Here we're being watched 24/7 every which way, from the bank's cameras looking at me at the ATMs to random cameras in the cities to buses, I guess, and everything else. And we're collecting a ton of, I don't know if people like that, but on the other hand, when they want to catch somebody or find a missing kid, we're awful grateful when we have this kind of stuff out there.
Yeah, I think that this kind of information, this kind of camera feed is more to catch somebody doing malicious things to the bus or to someone else that's on the bus. And
Or if they do it, how do we track them down? How do we find
yeah,
them?
I mean, if somebody pulls a knife at somebody on the bus, well, we now have images of that person, a little easier to track them down.
And we know what time they got on the bus and where they got off
Yep.
and when they got off, and et cetera, et cetera. Well, fascinating world you guys are into. I know you have a tendency to just think, we're just making a switch, and maybe that's the way or a router. That's the way the customers think of this stuff. It's just one little piece of the puzzle, but it's a critical piece because it's got to work all the time. It's got to work in severe environments, industrial environments, temperatures, moisture, vapors, things I never thought of. And it's got to be safe. This can't be the easiest point of entry into the system. It would seem to be the obvious point to break into stuff. I'm going to go hack the routers. Is that where people start? Or I know they have all sorts of other tricks to try and introduce viruses or gather passwords and other sorts of things.
Yeah.
Tricks of
the
humans.
tricks are usually what you need to do to attack a router head on is pretty difficult today.
Well, especially your routers. I hope and suspect that yours are of a stronger character. Do you ever go out in the field and support this, or you just send it to them and you send them a little tech spec on how to do this? I mean, do you actually support people in the field? Because that's where it breaks.
Well, and that's actually the fun part of this job is that our customers are some of the greatest people in the country. They really are amazing people. They welcome you in. We do our trainings, and we become friends with them. And it's not just
all over the
selling
world.
things.
You guys.
Well, I stay in the country for the most part when I'm talking to customers.
But you said you have an office in Poland and other
We do.
places. Yeah.
Yeah, we have Poland and in Taiwan, and I've been to both of them, and it's a lot of fun traveling. And like I said, I've visited some of the customers in those sites as well, and they're great as well. But I really like visiting our customers here in the U.S. They're just genuine people with genuine problems that you help fix and make them very happy.
How do they get in touch with everybody if they want to learn more? If we've piqued their curiosity, if everybody thought fiber in you, what's the big story about that? Hey, maybe there's a little more to this than I thought. Maybe I need to really revisit this or think about it some more. Is there a way to get in touch with you guys?
Sure, they can just they can call the office and then just ask for myself, David Zaveski, or just ask for any of the sales guys, and they can start the ball rolling with getting training. We do training all the time. If we're in their area, we have no problem stopping by and doing training.
Do you ever go out and evaluate the situation beforehand? Somebody says, I'm thinking about making my lipstick machine on the internet. Would they ever think to bring you guys in, or they'd bring somebody else in first, and then you're just sort of a piece of equipment that they research and bring along with them, whoever the consultant is that sets this whole thing up?
Typically, they'll bring in a consultant or somebody, or they'll design it in-house. But once the design is finished, if they are planning on using our devices, we will have no problems looking over their plans to see if there's
Makes sense. Something obvious they're missing here.
yeah, and most
simple.
of the time there's no problems, and we have no issues, and we'll even pre-program some of the switches before we send it to them, so that it's a little easier for them to implement.
Well, before I put it at the bottom of the ocean or at the top of a oil derrick, I think it would make sense to think about it one more time before I do it, because that little router, that little switch can make all the difference between whether it succeeds or fails, whether it breaks or someone breaks into it, and ultimately whether what I'm looking to do happens, right?
Right. It's just, it can't hurt to check one more time. And
Can't
that's what
hurt
we
to
do.
check. All right, Antaira. Spell Antaira for us, for those that can't spell here.
Antair.
Antaira.
Yeah.
Now, let's make sure we get the A in
Yeah,
there.
yeah,
Here.
yeah.
Okay. Well, you're an engineer. We didn't expect you to know how to spell
Yeah,
good.
well.
I are an engineer.
And-
That's
yeah.
right. Well, thank you for coming on, even though I'm sorry to make fun of you there, but
It's all good.
it is a fascinating world that few of us ever think about, but we're all being thrust into with rapid speed, as everything that you can touch or think of in an industrial environment, and maybe even in a consumer environment, starts to move and connect to the internet. We're going to end up with a world where my toaster is going to be connected. Every little piece of equipment is going to be connected. And I don't know that we're really fully prepared for what that means, down to the basic simple parts of what kind of routers and switches and fiber or cable and stuff are we going to use to connect all this. Thanks for at least getting us thinking about that here today.
Oh, no problem. Thank you for having me on.
Okay. Well, for anybody who's asking themselves, why would I listen to Making a Connection? It can't be that hard. It's more interesting than to think. Check us out, Making a Connection, Antaira podcast, as we talk with the people who are making a connection every day.